Okay, we're up to 833. Permission granted to be a little overwhelmed by how many formulas are getting thrown at you. So it's the goal of Pre-Calc to have you memorize all these formulas? No. I've been working with them for a long time. Some of them are like creeping into my permanent memory, but not many. So it's just a matter of manipulating them to understand them. So let's go. 833. You got, these are called sum and difference identities. So you can see we're adding the angles, subtracting the angles. Adding, subtracting, adding, subtracting. We've got sine, cosine, tangent. So the initial goal is just to let you mess around with them. So here's three problems that do not look easy at first, but they are. So with that being said, here's the first problem. And the instructions you have to pay attention to. It says use the sum or difference identities to simplify. Now I know you guys could use your calculator, just type that in decimal, type that in decimal, multiply, blah, 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 same. That is not the goal. You could do it, but you're not going to get the same answers. The goal is, look for this, cosine, cosine, plus sine, sine. So where is that? Well, not here. Here it is, right here. So essentially, we need to go from this looking thing to what it equals. So it equals cosine first angle minus the second angle. So here's my u, here's my v. Here's my u, here's my v. So I would go u minus v, which simplifies to cosine 10 degrees, and that's your answer. All he wants you to do. By the way, your homework problems don't reflect this. So why are you showing it to us? Just to kind of give you an idea of how to manipulate these things and warm you up a little bit. So now, sine cosine plus cosine sine. Where is that? Well, sine cosine plus cosine sine. So we got to go from there here. So what we need to do is take the first angle, or radian. In this case, it's a radian. There's my u. That means this is the v. And this is going to turn into sine of u, pi over 9, plus v, which is pi over 18. Yes, you could have converted this to degrees, but this goal is to force you to deal with radians. So we've got to find common denominators, so that'd be 2 pi over 18. So then this would reduce to sine of 3 pi all over 18, and that would reduce to sine of pi over 6. That's it. Now look at this. Definitely reflects one of these. Well, let's look. This has a positive in the top. This has a negative in the top. This has a negative. So it must be, this is connected to this. So if this reflects this, then this is really what we're being told to do. So this would turn into tangent of u, which is always the first thing listed, minus v, so that's 50, minus v, which is the second thing listed. 50 minus 25 is 25. There it is. So we just used the sum and difference formulas to simplify the crazy looking things. Those aren't that bad. So hold your hats, because here comes your actual homework-like problems. Okay, so here's your actual homework-looking problems. These are going to be a little trickier. Instructions specifically say, use your sum or difference identities to simplify this. Again, I gotta make this point. Anybody could go sine of 105 and get some decimal. That's not the goal. Somehow we have to use these formulas, and we got to take this, and because it's sine, we're either going to convert 105 into u minus v, or we're going to convert 105 into u plus v. Now here's the trick. When you pick u or v, your reference angles need to be 30, 45, or 60. That's the goal of this whole lesson. Heavy emphasis on your ability to deal with your 30, 60, 90s, 45, 45, 90s. You'll see what I mean in a minute. So if I pick something like 135, you're like, hey, that's not 30, 45, or 60. That's not the point. If I spun my spinner that far, my reference angle would be 45 degrees. So this is a definitely a good choice. It's random. I picked it randomly. So now we have 105. Well, what I'm going to experiment, because of that 5, is I'm going to take a 45 and see what I can do with that. So I'm going to go sine 45, and I go, wait a minute, plus 60. Notice, I got a 45, ding, 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 ding. I got a 60, ding, 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 ding. And now what I have is I have sine of u plus v. And that means I'm going to use this formula now. Now the previous 3 problems, we had this given to us, and we simplified it by using this. Now we're going the other way. So this right here equals this. So now you just need to put things where it belongs. So sine of 45, cosine of 60, plus cosine of 45, sine of 60. Now, we got to know what this is, and this is without a calculator. It's an exercise to force you guys to practice all of your special triangles. So sine of 45 degrees, here's my 45. Remember, that's 1 square root of 2. So sine would be opposite over hypotenuse. Now I'm going to go ahead and do cosine, seeing we're dealing with 45. Cosine would be adjacent over hypotenuse. So we end up with the same thing as sine of 45. That's just the way it is. Oh, my wife's calling. Give me a second. All right, so here we go. We're back. Duty called. So now, how do we figure out what cosine of 60 is? Well, you got to draw a different reference angle of 60, and then remember your rules. That's a 1, square root of 3, 2. What's cosine? That'd be adjacent over hypotenuse. What is sine of 60? That'd be opposite over hypotenuse. And now it's algebra. So I know a lot of people are focusing on the square roots in the bottom, but don't worry about that right now. We're going to multiply this. We're going to get 1 over 2 square root of 2. This would be the square root of 3 over 2 square root of 2. Notice we have common denominators, so let's just run with that. Now you can't add these, but we're going to write it as 1 fraction over the common denominator, and then we're going to get rid of that square root of 2. Notice I'm not worried about that 2 at all. I don't care about it. It's fine. You just don't want to leave radicals in your denominator. So square root of 2 to the top and the bottom. So distribute, so I get the square root of 2 plus the square root of 6. Now watch this. This is 2. 2 times 2 is 4. You can't reduce these because this is oil and water, so that would be your answer for that problem right there. Got to erase this. Give myself some space for the next one. All right, so now we're going to deal with cosine. And I grabbed a calculator. And if you want to follow along and practice yourself, please do so. So when we look at this, and it's given in radians, my advice to you is convert that immediately. So we know pi is 180, so 11 times 180 divided by 12 is 165. So we're going to write this as cosine of 165. Now remember, this is cosine. So we either need to find 2 angles that add up to 165, or 2 angles when we subtract them make 165, but our reference angles have to be one of these 3 degree measures. When I look at that, and I think, okay, 45 looks like a winner, I'm going to take 45 and I'm going to add it to 120. Now a lot of students get concerned about what if I had it in a different order. Doesn't matter. The formula will take care of it for you. So I'm going to go with my original. And here's another thing. If I tried subtracting, that would work also. So if I went 45 more than that, that'd be 210 minus 45, and both of these would work. So if I spun the spinner at 210, that would be a reference angle of 30. And but because it was the addition one that jumped out at me first, I'm going to use this. So here's my u, here's my v, and it's cosine, and it's plus. So I need to focus on this, and there's my formula. So cosine of u, cosine of v, minus sine of u, sine of v, and now we're off to the races. So I shouldn't have erased that 45, 45, 90, but whatever. Here it is again, 1, 1, square root of 2. We're going to get our information for this and this from here. But I also need a 120 degree spin, so why don't we take a look at that. So that's 120, which means 90 and 30. So there's my 90, there's my 30, leaving me with a 60 degree reference angle over here. So this will be my square root of 3, this is my 2, negative 1. Now with this, I can start working on this. What's cosine of 45? Adjacent over hypotenuse. Cosine of 120, that takes us over to this picture. Adjacent over hypotenuse, that's negative 1/2. Minus sine of 45, opposite over adjacent. Sine of 120, back to this picture, opposite over hypotenuse. So, square root of 3 over 2. Now you're going to notice that these answers are very similar, like to the last problem I did. But if I multiply this together, I get negative 1 over 2 square root of 2 minus the square root of 3 over 2 square root of 2. Again, we've got common denominators. I'm going to add op. So I get negative 1 minus the square root of 3 over 2 square root of 2. Get rid of that square root of 2. And so here we go. In the bottom, we get 2 times 2, which is 4. Distribute, distribute, we get negative square root of 2 minus the square root of 6 over 4. And we're done. All right, I got one more, I think, maybe 2 to show you. All right. I always like to nickname some math problems Mr. Nasty, and this one gets the award for this lesson. Starts out pretty simple, tangent of 15. So I'm like, okay, I got to figure out how to make 15, 2 angles that add up to 15. That doesn't seem likely, because it's like 10 and 5. No. So we're going to have to use subtraction. So how can we rewrite that 15 so it's 2 angles subtracting to get 15? And again, that 45 minus 30 is my 15. Different possibilities out there, but that's the first one that jumped out at me. So here's my u, here's my v, and I need to plug it into this, which means I really have to plug it into that. Now you might say, well, why is that such a Mr. Nasty? Well, watch. Tangent of 45 minus tangent of 30 all over 1 plus tangent of 45, because that's tangent of u, which is this, times tangent of v, which is 30. Now watch where this takes us. So we got to have a 45, 45 again. So there's my 45, but we also need a 30 degree reference angle because of this and this. So here's my 1, here's my 2, here's my square root of 3. So let's start plugging things in. So what's tangent of 45? Opposite over adjacent, 1. Minus, what's tangent of 30? Opposite over adjacent. So it's minus 1 over the square root of 3. 1 plus tangent of 45, again, is just 1. I don't need to put it in here, but I will. Tangent of 30, we already figured that out, is 1 over the square root of 3. Now, why is this so nasty? Well, you can see we have a complex fraction here. So I'm going to add op into the top, and I'm going to rewrite that. 1 plus negative 1 over the square root of 3 over, and that's 1 plus 1 over the square root of 3. Now, Different students do this differently, but I'm going to show you the way I think students look at this, and it really makes a lot of sense. A lot of students I've seen like this method the best. They're going to multiply the top by the square root of 3, and they're going to multiply the bottom by the square root of 3, just to eliminate the confusion in both the top and the bottom. So let's see what happens. So we multiply that by that. I'm going to go ahead and get rid of this. Running out of workspace. So that would be the square root of 3 minus, these would cancel, minus 1 over, distribute. I get the square root of 3 again, and then these cancel, plus 1. Now I know the temptation is to cancel these, but hopefully by now you know you can't unless these are connected by multiplication. This is where we go, wait a minute, forget about the numerator. How do I get rid of the radical in the bottom? This is why we practiced this a few lessons ago. We got to multiply that by the conjugate. And then so we got to multiply that by the conjugate. So this is really an algebra nightmare, not so much trigonometry / pre-calc. So in the top I have to FOIL. So there I get 3. Outside, negative square root of 3. Inside, negative square root of 3, negative 1 is 1. I'm going to clean that up. 3 plus 1 is 4. These are like terms, minus 2 square root of 3. There's the top. Notice if I go outside, inside on these, those would cancel. So I'm just going to go the F part, square root of 3, square root of 3 is 3. Positive 1 times negative 1 is negative 1, so 3 minus 1 is 2. Almost done. Take a 2 out, take a 2 out, take a 2 out. So this would be 2 minus 1 square root of 3 all over 1, which means we're done. Whew! One more problem, guys. All right, so this one you can see they've already put in u plus v form. So they've taken care of the hard part, in my opinion. And now you got to realize, what is this? Well, that's the same thing as 135 plus, and that's 2 times 60, 120. Now I know you guys would be tempted to add these together and then just take sine of 2, whatever that is, 55. That's not the goal. This is u, this is v, and now we have to plug it into this. So that would be sine of 135, cosine of 120, plus cosine of u, which is 135, sine of 120. So, spin your spinner 135, that would be right here. So 135 is there, leaving us with this 45, 45, 90. Don't forget that's negative, that's huge. So let's take care of this and this right now. So, sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Now we need a 120 degree spin. Well, that would leave us with a 60 degree reference angle. There's our square root of 3, negative 1, 2. So what is cosine over here? Adjacent over hypotenuse. And then sine would be opposite over hypotenuse. And so we'd multiply this together, negative 1 over 2 square root of 2, plus negative square root of 3 over 2 square root of 2. And I think you've seen this before. 2 square root of 2, get that square root of 2 out of there, get it out of there, out of here. We've got to repeat it here. So we'd get 4 in the denominator. It's going to be messy, but negative square root of 2 minus the square root of 6. So there's my answer. And they already put it in that form, so we just kind of went for it. All right, that's it. Good luck on your homework. I think you guys got this. Like and subscribe.